In this video, we're going to be speedrunning all of the solutions to the USA Biolympiad 2011 open exam. So, first question, all the following processes involve hydrogen bonding except for which one? So, I already answered this one. So, A, DNA replication. Well, DNA replication, you use, in between the base pairs, you have hydrogen bonding between the complementary base pairs. And then formation of ice crystals. Well, ice crystals are made of water, and then there are hydrogen bonds in the water molecule, so that use hydrogen bonds. Now next for binding of enzyme and substrate. Hydrogen bonds are common in the non-covalent interactions when you have enzyme and substrate binding. And then protein folding. Well, you know that hydrogen bonds stabilize the secondary structure in the alpha helixes and the beta sheets. So all of them use hydrogen bonding, so the answer must be E. So let's move on to our second question. Of the cellular compartments listed below, which one that has the lowest pH? Well, the lowest pH, that's going to be C. And the reason is because lysosomes are acidic. And acidic is, the pH is going to be approximately 4.5 to 5. So, and remember, acid is going to be like a low pH. So, acidity, and that acidity is mainly maintained by the proton pumps. Which are the VATPases. And the mitochondrial matrix is alkaline. It's like alkaline. So that means there's like a pH of approximately 8. Cytoplasm is almost neutral. So that means that it's approximately like, it's near neutral. It's like approximately 7.2. And then endoplasmic reticulum, it's like kind of basic. Slightly basic / neutral. And cytoplasm and the nucleus, they're both about approximately 7.2. So that just leaves us with C. Now, let's move on to our next one. So a digestive enzyme, when you have something that's digestive, it's because it's digestive, it has to be acidic. So it's why it makes sense that's the lowest pH. Okay, listed are 3 statements about lipids. Lipids are made up of polymers of fatty acids. Lipids are hydrophobic, and lipids are made up of fatty acids with a high degree of saturation are more likely to be solid at room temperature. That's true. So, okay. We know that lipids are not polymers. They're not polymers. So, there's no repeating monomer. There are no monomers. So, that means that it can't be a polymer. And we know that lipids are hydrophobic. That's a very, very simple thing about them. So, we know that 2 and 3 are correct. So, that means our answer is going to be our answer is C. Okay, so now for question 4. A spectrophotometer is used to measure the concentration of proteins, DNA, and many other chemical compounds. Assume the input light intensity at a particular wavelength is lambda I initial, and the intensity of the light transmitted through the second curvette is I initial, is I1, and the concentration is doubled. Which of the following is true? Okay, let's see here. Well, we can use a Beer-Lambert law. The Beer-Lambert law. Well, that's going to be A is equal to this symbol Cl. And absorbance is going to be proportional to concentration. So if you 2x the concentration, it's going to 2x the absorbance. So let's see here. So we doubled it, so that means that your answer is going to be B, because the absorbance A lambda of the second will be twice the absorbance of the first, because it's just directly related. All you have to know is just this Beer-Lambert law, and just be able to understand the relationship with it. So percent transmission is not linear. That's not linear. It's not a linear relationship, so it's not 2 times. Wavelength of max absorbance doesn't shift with wavelength of max absorbance doesn't shift with concentration, so that's not dependent on it, and there is sufficient information, so those are wrong. Okay, so what is the concentration of hydrogen ions at pH of 5.7? You don't need a calculator. Okay, so what this means is we know that pH is equal to negative log of the concentration of hydrogen atoms, and we know that the pH is going to be 1 times 10 to the negative 6. And we know that pH of 5.7 is slightly more acidic. So that means that it's approximately going to be like 2 times 10 to the power of -6. So that's no calculator needed because it's about 2. So 5.7, we know it's just going to be kind of a little bit more because it's a little bit, 5.7 is close to pH of 6. So that's why we can kind of infer that. So you have to kind of be able to estimate logarithmic scales mentally. So that means your answer is going to be B. That's just what we wrote there. Okay, which statements are true about amino acids and nucleotides? Okay, so both contain peptide bonds, both contain nitrogen, both may form helical structures. Nucleotides and amino acids form branched polymers. Okay, both contain nitrogen? Yes, they both contain nitrogen because you have the nitrogenous bases. And you also have the amino groups. And the proteins and nucleic structures, peptide bonds. Amino acids contain peptide bonds. No. Actually, no, not this one. Because only proteins do. Nucleotides don't have peptide bonds. Not nucleo. Okay, now both may form helical structures. Yes, because they can both, because like, you know, the 3D structure of the protein. And nucleic acids, of course, they form like the DNA helices. And branched polymers, no, they don't both form branched polymers. And both contain phosphate groups. No, not amino acids. Amino acids. We know that it's we know that it's chomp for nucleotides. And so that there's phosphorus, but they both don't contain phosphorus because proteins have no. Proteins is no, I mean like nucleotide, and then chons is for protein. Okay, so next question. A variety of different techniques are used to separate, analyze, and purify different chemical compounds. Select all of the following techniques that can be used to estimate the molecular weight of a protein. Okay, so let's see here. Electrophoresis, SDS page. Then we know when you have that, your migration is going to be proportional to the size. And size exclusion gel chromatography, the elution time is going to be proportional to the size. But the other ones separate by charge and binding. So no. So that means it's just B and C. This one is just select all that apply. That's kind of like mean. Which of the following doesn't apply to chloroplasts? Okay, so chloroplasts. This is a discarded question because it contains multiple correct answers. So you can actually skip this one. Okay. So, let me read. Okay. Use the following pathway to answer question 9 and 10. Many metabolic pathways involve multi-step reactions. Consider the following pathway where E represents different enzymes and A, B, C, D, and F represent substrates and the products of the pathways. Okay, so feedback inhibition of this pathway may involve let's see here. The byproduct, the product of the final reaction F interacting with and inhibiting E1. Feedback inhibition. So feedback inhibition is the end product inhibits the first committed steps, and it always targets E1. It prevents wasteful overproduction. That's why this thing is a thing in the first place. It's not what the question's asking, but we know it's A. In the example above, assume that D is an allosteric inhibitor of the enzyme E2. Then D would, okay. Well, allosteric inhibitors, what allosteric inhibitors do, they bind away from the active site. They also change the enzyme shape, and they prevent substrate from binding indirectly. So allosteric doesn't mean competitive. Allosteric is not competitive because it doesn't compete with the active site. Competitive. So competitive inhibition is at the active site, not allosteric. So allosteric inhibitor, let's see here. The correct answer is going to be D because it binds E2 at a site different from the active site, but change the shape of the active site so that B can no longer bind. Yeah, so it's going to change it. It's going to inhibit it, and it's going to change it, but it's going to bind at a place that's not the active site. So yes. Okay. A plant cell with a volume of negative 0.8 MPa maintains a constant volume when bathed in a solution that has a solute potential of negative 0.25 MPa and is in an open container. From this information, one knows that, okay, so, well, we have to use the water potential equation. So we have this symbol here is equal to this thingy S plus this thingy P. And okay, the outside solution from the open container, you have an open container, so that means that your thingy is going to be, okay, outside is going to equal to negative 0.25 plus 0 is equal to negative 0.25 MPa. So, okay, so for no net water movement, you have that the thingy cell is equal to the thingy outside. So then you can say that's equal to negative 0.25. And that means that you can plug this in. Okay,